Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Nurauni binti Adam and my matrix number is GE220028. So today I would like to present my project, my project is about non-invasive blood glucose, and I use the method genetic algorithm to get the optimization for that equation. So let's start with the manual calculation. So manual calculation, start with the equation, and the equation that we get from the data, we get the function equal to 9 times 10 power of negative 6 x squared plus 0.1788x plus 49.454. So at here we could know that we have two variables, which is x squared and x, and we substitute with the a and b. So first we need to do the step 1, which is initialization, and initialization is where we initialize the value of a and the value of b. Then we do the population, which is in this case we do the 6 population, and then next step is the evaluation. Evaluation is we need to evaluate the function object, and we need to do until the population also, which is 6, and we substitute the value of a and b. So next is step 3, which is step 3 is selection. So in the selection we will do the whether it was the best fitness or not, and then we will find the probability and cumulative. So next also we do the random variable. So in order to get the random variable, we just pick out, and for the new chromosome we select by the rule, which is chromosome decrease then random number and decrease then new cumulative. So next is the step 4. Step 4 is about the crossover. Crossover is actually we do the cut off sum of the value, and we pick another value. So at here you could see the value, the blue value is actually the new one. So we pick as a random number 1, 4 and 5, and then we do the crossover chromosome between them, and then we could get the cumulative 1 as 1, cumulative 2 as 1, and cumulative 3 is 2. And next we could get the new chromosome with the new value of a and b. So lastly is we do the mutation. So mutation is the formula is total gen equal to number of gen in chromosome and multiply with number of population, and we could get the number mutation. And the number mutation is we get the approximately as 1, because we get the 1.2, and then we do the mutation between 02 and 05, which is at chromosome 3 and chromosome 5, and then we do evaluate the function object, and then we do the new chromosome, and we could get the new chromosome, and we do the same process as the previous. So at here, this is before this that I run, and because this, when we run, every time we run, the value will be exchanged, and it will give our best fitness function at the time. So this is the optimization, and the current iteration for this is 116, and the objective function value is 5.02, and the value of A is 32.605 and the value of B is negative 276.642. So when we substitute this value in the equation, we could get the negative 49.473. As we know, when we round off the negative 49.473, we could get negative 49.5, which is negative 49.5. We also get negative 49.454 because when we round off the negative 49.454, we could get negative 49.5. So at here we could know the value that we obtained is true. So next we will do the demonstration. So I will back with the MATLAB. So at MATLAB, actually we use the optimization toolbox, but this one we need to declare first our function. So that's why we have to coding the function at the editor. So this is our function, and then we need to run, of course. So we run, and then we take the apps and we take the optimization toolbox and add problem setup and result. We choose the GA, which is we want to do the genetic algorithm, and for the fitness function will be alias my fitness, and then number of variable as we know is 2, so we choose as 2, and then for selection we do the roulette. So we start. So when we start, we could get the iteration as a 1 to 5.493 and negative 277.38 as our value of A and B, and the current iteration is 151. And when we try to enter in the calculator, I will show you guys. 0.1788. So we put as A as 1 to 5.493 and B is negative 277.38. So we could get, as you can see, negative 49.45. So actually negative 49.4538 we get same answer as the left hand side, which is the before this, which is negative 49.454. So and here we could know our simulation is true and the genetic algorithm can give us the best value. Also at here, before I forget, we can generate the best fitness function for the graph, stopping iteration and selection and max constraint. So we just put start again, and this is our value that we could get. So this is the selection function best. So our best fitness is 6.93061 exponent negative 5, and our mean is 0.493, and stopping criteria is actually at here around 40 to 50, and this is number of children, which is we could get the latest, the last one is 50. So that's all from me. Thank you.